So we've moved on to part B of our compressed spring problem, and part B says that we have a 20 kilogram box resting at the end of our compressed spring, and after releasing the spring, the kinetic energy that we measure does not end up the value that we expected, since the box had slid across the ground with a coefficient of friction of 0.2. So what we want to know is how much work was done by friction if our box moved 3 meters. So obviously we have a case of energy not ending up where we expected. We probably had calculated our kinetic energy to be equal to our initial spring potential energy, but as things go, work done by friction took some of that energy, and we didn't end up with as much kinetic energy as we expected. So all we want to do in this part is to calculate how much work was done by friction. So of course the equation for work is just force times distance, and our force here is going to be force due to friction, which is equal to the coefficient of friction times the mass of our box times acceleration due to gravity, and then after all that, just times the distance that our box moved. So again, just like part A, all we have to do is plug in our values and calculate this work done by friction. So we have our coefficient of friction of 0.2 times 20 kilograms times 9.81 meters per second squared, and then times our distance of 3 meters. And all we have to do is calculate this once again, and what we end up with is 117.72 joules, and that's a lot of work done by friction. If we compare it to the value of 128.6 joules of spring potential energy that we started with, all of this energy went into work done by friction. So we're really lucky that our box even moved 3 meters, because that's just like 11 joules of energy going into kinetic energy. But regardless, this is how much work was done by friction, and with that we can move on to part C.